Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 155, maximum profit from valid topological order in DAG. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one I think is a weird one. Keeping in mind that I'm recording this video about, I don't know, 2 weeks after this contest happened or something like this. So I don't know all the details about the context and stuff like that. But my understanding from what people told me on my Discord is that there was a wrong solution, there was a greedy solution. So all kind of rankings with respect to this problem is just awkward and incorrect, right? But in any case, even aside from that though, because my understanding is that they thought greedy worked, and if you actually look at my solution, I also thought greedy worked because I got two wrong answer. But the thing that is regardless though is that yeah, they set n is equal to 22, which is just really silly because they want an n times 2 to the n solution, which makes this really tight for certain. Like you have to do certain kind of pruning to just get a little bit lucky, right? You'll never be confident that you have a good enough solution because, well, yeah, you're just never that confident because it just depends on how many test cases they have, what kind of test cases they have, and etc., right? Like if you ask me, I can fail any problem, you know, with just like, yeah, a couple of test cases, so that makes it a little bit silly. But anyway, let's just pretend that Leetcode is not stupid and n is not 22 and n is like 18, right? Then what would happen? Well, then this is just becomes a bit mask dynamic programming. The reason why this is bit mask dynamic programming, honestly, is just because n is small, and even 22 maybe in some languages is probably fine. I don't know, right? Is that you can then now do n times 2 to the n. You still have to be a little bit careful so you don't do n squared times 2 to the n, which happens in some cases. But yeah. And bit mask dynamic programming is a very fancy term, but really it's just knowing or possibility where the possibilities are 2 to the n number of possibilities, right? And the bit mask part sounds a little confused or like maybe a little bit tricky if you're new to it, but it just means a boolean array, right? And I took a peek at this, and I actually, if you watch the live portion of this, if you watch the live portion of this, oh jeez, I have to find my old solution. If you watch the live portion of this, I actually was trying to play around with it after my submission got accepted, so that's why I was trying to convert it to bottoms up from top down. I don't know why this page takes so long to load. So yeah, you can see me playing around there. But this is probably what I would recommend, assuming that Leetcode is not silly of writing, right? And yeah, and keeping in mind that for me, this p, so there's two things. P is, mask is 2 to the n, right? P is, well, this p is this position thing. So it's going to be 1 to n, right? But and this is number of number of nodes used, right? Kind of. But keeping in mind that of course bit mask will have the number of nodes used that's equal to p. The p does not give us any, or it's not a distinct state, right? Because you could p is a function of mask. For example, if you rewrite this as p is equal to I guess we can write it after. P is equal to mask dot bit count or something like this, or n minus this, and it would give you the exact same answer, right? And it's just that writing it this way just allow, I don't know, maybe just a shorthand that allows, it's just a little bit easier for me. I don't know if I recommend it per se. You could probably test it to see whether, because you do store it in the space, but it's fine. Anyway, so okay, I just want to get all that out of the way. But now let's pause, step back, and kind of explain the problem, right? So how do you want to do? What is topological order, right? What is topological sorting, right? And there are a number of ways to do topological ordering, but the idea is that for this particular problem, you have a choice, right? Basically, if if at any given time you have multiple nodes that you can choose, well, and you can choose those nodes because all the prerequisites are met, then which one do you choose? That's basically it. And there's no greedy solution. It's just a brute force try every possibility solution, right? And because n is equal to 22, even though it should be 18, we just set it up to kind of do this as efficient as we can with a bit mask. And keeping in mind that bit mask, as we said, is just a bit vector, right? And how you would think about it is that it's just like a ones and zeros, and you could even think about this as like a Boolean array, right? Where it means that at it's least significant first. So technically, the first bit is true, the second bit is true, the third bit is false, and you could kind of make this define. Let's just skip the rest for now. And you make it define as that. So the ith bit is true, is 1 if we and you can define how you like. For me, I vote if this node is available to be picked, right? So that's basically how I define the mask. And once you do that, then now if mask is equal to 0, that means that all the nodes are done, so it returns 0 at base case, right? Otherwise, we just set best is equal to 0. If so, what this is saying is that if this bit is 1, then it is available to be picked. That's what this does. And this is a little bit trickier. It's basically saying that, okay, I forgot to explain this part. I guess I actually don't use you to do. I think I realized this. But basically what this happens is that this is saying, okay, for a given v, the requirements are represented in a bit mask, right? So here, you can also think of this as a Boolean array. Basically, it's saying, okay, well, in order for us to do v, u has to be done, right? The uth bit has to be done. And then the parents of v would represent a bit mask that has, like, you could think of it as a list of Boolean values of all of them, right? And in here, this allows us to do that in really fast time by saying that, okay, well, this is the mask is all the things that is available to be picked. So if the prerequisites are if any of the prerequisites are available to be picked, that means that they're not done, right? That means that you have to, after you pick it, then it is done. So that means that, if there are any prerequisites that are still in the current mask, then we just skip it, right? So if there are no overlaps, that means that all the prerequisites are done, then we do a recursion, which is this part is more straightforward, and maybe this, we get rid of the ith bit, we increment p, we update the score. Keep in mind that p is just the thing that's in the function somewhere. I forget where is it. Where is this? Oh, the product of the right? So here, so p times the score, and that is the score of that. This is the best recursive score of when you have only these nodes left, and that's it. And then you take the max of all of those, and that's it. Here we initially set up so that all the bits are available. There's only one. You start the first node as p is equal to 1, and that's it. What's the complexity here, right? As we said, mask goes to 2 to the n. This p is deceptive because it's not an extra thing. So that means that, okay, there are O to the time m number of possible inputs. Each input takes O of n time to kind of do this loop, right? So in total, it takes O of n times 2 to the n. And that's basically the idea. And you also say it takes O of 2 to the n space because it only takes O of 1 space, right? So that's it. It's kind of it's not that bad. I spent a lot of time afterwards. I spent a lot of time afterwards just like trying to optimize or try to do it bottoms up and playing with some optimization, which is a really silly. But yeah, that's why I said by Leetcode sometimes just don't know what it's trying to do. I don't get what it's trying to do with the constraint, but the problem I think is fine. It's a good problem, even fun problem to do, a fun problem to kind of mess around with. And there is a fun optimization with this part to optimize array and square array to all of n. Anyway, all that you can watch live next. Let me know what you think. I did thought it may be greedy, but I was just wrong. I mean, there were inputs that shows it's wrong, so it's very easy to show it's wrong. And that's it. Thanks for watching. Stay good, stay healthy to your mental health, and you can watch me solve it live in the contest next. Okay, let's YOLO submit. No silly mistake, please. Okay, good. Okay, how are we doing? I mean, these I feel like used to be more helpful, but now it's just whatever. Someone got queued for in 3 minutes. That's not great. Okay, DAG. Sorry, friends. Okay, you have a DAG. Each node has a score. Rather topological order. One base position. What? What does that mean? I don't know what that. Summing the product of each score and its oh, okay. Still kind of confusing because why? What does one base mean? Oh, did you just kind of give an example? Okay, processing order. So okay, Oh, I see. So the order that you process them will be given the score multiplier. So you want to do. So isn't it just greedy? It's greedy over subtree. It's not greedy over one node, right? So because every time you delayed one, then you add the sum of that. Okay, fine, it's linear. And n is only 22. That's actually interesting, maybe. Okay, so there's a lot of graph. I had to divide it in order. It's a DAG, so there are no cycles. So that means that all of them will be. Yeah, okay. No, this is pretty straightforward. Yeah, I mean, it's fine. It's not. It may be annoying to implement, but it should be straightforward. If I could type it correctly anyway. Okay, so then now score. What is score? Score is the node, right? So it's a sum of all the previous nodes. So yeah, okay, we'll just do a depth first search on this one. Yeah. I like to call things go just because I don't want to deal with remembering it. Okay, so node, right? For b in e of node. And this is actually score of node, right? Okay. So then now, okay. And then now we want to do, oh, well, we have to, yeah, I guess we don't have to cache it. It's already done. Okay, so then now, we do buffer search one, right? Okay, yeah. I guess I could put in here. E of in degree of v is equal to. Okay, so then now for I in range of n, if in, why do I have a thing on it underscore? If it equals 0, q dot append I. Well, no, I mean, yes, but no. That's too standard. What we want is a heap, right? So heap. We have h. We have the score sub I. So go of I and I, right? Okay, I think that's good enough. We want the lowest, right? Okay, and then while maximum means that we want the minimum first because it delays them, right? Okay, we also need to do the order thing. Okay, fine. Yeah, you got a 1, I guess. Shouldn't matter. Okay. Okay. So the current score doesn't matter, and then index is equal to h, right? And then now total score. Total score we added by the score of index times p, increment by p, increment p, and then now for v and e of index. I don't like about index. I usually write current, but okay. In degree of v subtract by 1. You go to 0, then we just do the right? H go v, and I think we're done. 825, okay, YOLO submit. A little bit rushed. Oof. Huh. Is my greedy wrong then? Or am I just, because this is, okay. I was hoping that was right, but expected, okay, so 0, 1. Oh. Wait a second, So 0, 1, which one do we do first? I might not have, no, I was gonna say it might not have handled the no edge case, but I think I do. Unless I'm wrong. This is off by 4,000, so maybe it is. I don't know. Okay, it's 201, so it does this one first, and then 0 and then 1, right? Because in theory, so this is 5 plus exchange algorithm, right? I thought this would be right, actually. Okay, so 2. Okay, let's just do it this way. Maybe that's slightly better. It should be min, right? Okay, and it's missed by, was it 30-something thousand? That doesn't even make sense in a way. But okay, so that's this first because this subsum is 70,000, which makes sense. How do I get 28,000? Huh. Okay, I have to bring up a calculator. So let's say we do 0, 1 first, right? So let's just say, whatever, right? It's either this or maybe I did something else wrong. Let's see. Okay, so that definitely is better if I did the 0 first. So my assumption about doing the min is wrong, but the max isn't right either, right? Okay, so this is harder than I anticipated. Or, I mean, I think my math is just a little bit off. So what is the exchange argument? Do we always do the minimum first? So it's not this one? Is it just score sub I? That doesn't feel right though. Because I feel like it unblocks some stuff, right? So it's right for here, but I'm not convinced this is right. Am I going to get another wrong answer? A lot of people got 2 wrong answers actually, but I'm not convinced this is right because this... Actually, maybe it is. Okay, well, clearly it is not. I don't know, I was just YOLOing. Okay, so greedy is a little bit awkward then, huh? I didn't think this would work, but I thought there was an exchange argument on the sub of the trees. Oh, okay. Maybe that doesn't make sense because maybe we have to do a comparison between 2 nodes, and a comparison is based off because the okay, exchange argument on the greedy, but I think my exchange was wrong on this case. on this case, because exchange this one, and then these two will be at the same level, and then you do this one. So that's why this makes sense. But how do you do? So that's why this code kind of works for that one. But then for this one, what is the idea, right? I have to draw the tree out a little bit. 1, 2, 2, 0, 2, 3, 1, 2, 4, 2, 2, 3, 1, 2, 3, right? Okay, so then the first decision is 0 and 1, because they're on the same level, right? Okay, so let's say we do 0 first. Okay, and we do 0 first, I think. No, we do 1 first, because 1 has the minimum thing. Okay, actually, I just read it wrong. But okay. Okay, so then now we do 1 first because of exchange argument, and then now you have 4, 0, 2, 3 to do. Oh, well, no 3 because it has to be either 4, 0, or 2. And then does 0. Why does it do 0 and not 3? Well, 3 is small, so there is some function here where this doesn't make sense then. How do you do the exchange argument? Right? The exchange argument is such that the sum of this node is smaller than this, right? I think one thing that I forgot is that n is 22, because we can sort this, because I was trying to keep everything in a heap, but I don't have to. I think I'm just being dumb. Because I was trying to optimize for the heap part, but what I should do, we can do a much slower sorting thing with the exchange argument, right? So that's probably the reason, because basically what we're saying is, okay, we do the whole subtree and then do the thing, and not even that actually. It's not always just the whole subtree. It is a subset of nodes which is in the subtree, right? Because here it does here it does 3 last, which it should not be doing. But the reason why 3 is last is because 2 is 2 is the prerequisite for 3, but we actually want, wait, is it? Yeah, we actually want to do the 4 first, because then the 4 give us the benefit of pushing the 90s, this one back. I guess that's the difference, is that we want this to be pushed back. How do I do it? I mean, I guess the key thing is that this 22, and I didn't take advantage of it. I just thought it was going to be greedy. Okay, so then here, how do we get the next thing? So we have to write a comparator function, I suppose, to get the min. I honestly, I do want to write a bitmask DP, but 22 seems a little bit high for it. If it was like 20, I would have done it, or maybe a little bit less. It's 20. It's not bitmask DP. I just can't get out of the bitmask DP idea. Okay, so this is definitely wrong. It's not bitmask. Is it bitmask DP? Well, 22 times is like 88 million or something. That's too much. That's too much. No, it's a DAG, so maybe a lot of those are not possible. But that's such a crappy thing that they make you do, though. Just if it's bitmask DP, just give us bitmask DP. Okay, fine. Okay, how do I want to rewrite this? Maybe this is fine so far. But now, I mean, it's just bitmask DP, I think. But we have to do a lot of pre-processing, and also maybe that it still times out because Leetcode is Leetcode. It's a lot of work. Okay, and then now we have to get I don't know if I need this one. No, because then it's like, because we have to look at every edge, then that's too much, right? We have to look at every parent, that's too much. I mean, it's 22, you could do it in bitmask, right? So I think that's fine, maybe. It's a little bit annoying, but it's fine. Okay, so parent is times n, and then now parent of v. Okay, maybe that's fine. And then from this, you can just write for I in range of n if parent of I and mask is equal to 0, then we do go. Okay, maybe that's fine. I don't know. Go mask. We flip. We can add a thing. I mean, this thing is deterministic, so I think that's fine. We can just do the math. No, it's plus score sub I times P. Oops. Right, something like that. Missing one requirement. Yep. bit mask and oh, I have to check whether no, it's greater than 2. Okay, you got this one right, you got the other ones right. I don't know if this is fast enough, honestly, but I'm gonna YOLO submit. Because Leetcode is like really weird with timing, and this may timeout exceeded, but that's fine. We can rewrite this. Maybe we can rewrite this bottoms up, but I guess it's gonna time out. But I think the idea this is fine. Right? This is just 22 times. It's like 88 million. Oh, that is actually surprising. Okay. Yeah. I mean, that's good. That was very, but that's such a guess. I don't know why they make you do this, right? Because what is that, like 20 seconds? Actually, right on the dot. I don't know why they make you like I have to guess that that's good enough, right? And I wasn't even confident. Like I definitely could have. Yeah, I could definitely had to YOLO a little bit on that one. And not, you know, but yeah, I mean, I feel like that this is an okay result. I mean, definitely one of the solutions were kind of dumb, but yeah, how did people do it? I guess, yeah, I was debating. Oh wait, did they do it top down or bottom? No, yeah, they do it bottoms up. I was debating doing it bottoms up, but I don't know that it's going to be that much slower though. Or it's that much faster. Yeah, I don't know. How did they do the ordering? Maybe I could learn a little bit from ChatGPT. Oh, yeah, this part I guess I could. I don't know if this is that much faster, but okay. For mask. Oh yeah, I guess this is actually reasonable. Okay. Yeah, maybe I need to do a little bit better on that because increasing. Okay, fine. Let me actually practice rewriting this. Right. Okay, DP is equal to C is fine. Right, and now dp of 0 is equal to 0. Whoops. So maybe this should be negative infinity. Just looking at the constraints. 10 to the 5th times 22 should be fine. Let's just do 18. Because this is a lot of. I don't want to use big int here because this could be a lot of elements. Usually I don't mind, but yeah. Okay, so then now for mask in range. Right, and that's pretty much it. And then P is you go to. I guess if we're going to use like. I mean, I knew that wasn't going to be a thing, but yeah. So then now for I range of n, right, bit dp of mask is you go to max of dp of mask currently, if I can spell that correctly, and then dp of mask, right, and that's it, except for the add if statement, which we have here. So let's just copy paste it. Yeah, and then we just return dp of mask of -1, right? Well, okay, that's not right. It's not right because I forgot the add function here. Silly Larry. It's this one, right? Yep. Actually, this isn't so bad. I feel like maybe I should have like, I know that we passed. Is this right? I don't remember anymore. Well, 7 and 18 is not right. But yeah, I know that it passed anyway, but it's such a... oh, this is... Because I did do it the other way. So this should be n minus this plus 1 or something. Yeah, okay. That looks more right. So let's give a quick submit. I know that it passed, but I probably should have done this. This took like 2 minutes, right? to do, or not even. I guess 2 minutes is maybe a lot, but also not that much. The reason why I'm and for this particular problem it's a little bit split is because here you have to initialize the entire thing, right? Oh, that's that's the part that I wasn't sure about, because this. Yeah. Because now we do all of them with we did it top down. If we did it top down, then we only care about like we don't do all the states that are impossible. So I wonder if they do any. If this guy does anything about it. Okay. Oh, I see. That makes sense. I guess I could. Yeah, maybe I'm just not thinking. But yeah, but basically, if DP mask is wait. No, I guess they do a push, right? Yep, they do a push. That's why I was like, that doesn't make sense. But that's because I do pull instead of push DP. So okay, let's rewrite this with pull then, push then. Okay, this is do. Then now, okay, so then push is just do, right? But okay, I do kind of actually, honestly, this is a part of my thing that I'm not as strong about, as you can see, because and a lot of times push and pull doesn't make a difference, but in this case it clearly does. So yeah. How does this work? So okay, so yeah, the if statement has to be changed because I'm now doing pull. That's why I'm a push, but that's why I'm thinking about it. But so we're pushing. We want this to be. No, then this is not right, right? Okay, so pushing. So we want this to be 0. So that means that we push it to 0, and then we're using this. Maybe this part is fine actually. No. This is parent sub. No, this is fine. Maybe I think. Maybe not. I don't know. Let's see. No, this part is not right. This part is fine. We start at 0. We say okay. We go to I. We go to I. So it has to have 0. And then this one just feels a little bit weird. How can we say we can get I? That's such a weird optimization that you need to make though. But maybe I don't know. Okay, let's see. Oh, I see. I guess I did know this, but did that work? No, this is still wrong. Yeah, now I'm totally cheating, but if this is 0, 0 and I guess we also don't need this, but what am I doing wrong? DP mask score sub I. We want to add I, so we want to push it, right? That should be right. What am I doing wrong? My masks are different, so I guess I can't just copy this. I mean, this part I think is right, but I think knew that this part is a little bit wonky even before. So okay, so let's say we get I. I is when okay. So I think it's maybe I should have known this. I think it's this. Nope. So, okay. Am I just being dumb? Okay, well, that's definitely not it. I mean, this part is definitely the wrong part, I think. But okay, so going from I, that one has no more requirement. The parents of I won't have I in it anyway, so this shouldn't do anything. Okay, what? Okay, so the mask. Can't believe it. Actually, it's so hard to convert it the other way, huh? Okay, so if the mask and this is equal to 0, that means that there's no bit there, so we can push it because we're coming from there, right? So okay, so this part is fine, but this part is a little bit awkward. So you want this mask, so from there you do this should be right. Why am I so wrong? Okay, at least we have this, so we can go over this one with 0, 1, so that should be pretty straightforward. Did I just do it backwards? Is that why? Okay, 13. How did I get 13 anyway? Is it just because I did the math wrong? That would be funny if this is just wrong. Okay, I guess I'm just being dumb. Why is that? Mass.bit count start at 0, so P is 0. So why would this be right though? I don't get it. The numbers are right. That's YOLO submit, but it looks right. But what? This would be 0 for mask is equal to 0. Oh, okay. No, that's right. I'm just being dumb. The 0 case is not 1 case, right? Okay. But yeah, but in any case, I don't know. It doesn't even seem that much faster, if any, as we'll see. So, and still time limits exceeded. So that's actually kind of sad. Maybe so we need to make one more adjustment, maybe. And I'm going to cheat for that one. Honestly, I don't know. I would have thought that this is good enough. But maybe not. I mean, at this point, I'm like just copying and pasting, and I don't even see how, other than the subtraction. Like, I don't know. Like, we're just doing performance-y things, right? How close are we? Did it say? So still like 12 cases. I don't know. I mean, I guess we are doing a lot of bitmask stuff, right? So it is a little bit awkward. Like, was it 782? And this is like way Leetcode specific now, right? So that's just wild. But yeah. Okay. So next is you go to. Oops. Right, so then now, I mean, it definitely, okay, fine. It has no thing, but it's got, I don't know, it's wow, you can never go right. Like, even if I had gone this way and it was fast for me to do the conversion, it would have taken even longer time. I don't know what to make of that, to be frank, but, yeah, did it get further at least? Nope. Yeah, I don't know anymore. I get. I mean, this doesn't need optimize. Maybe we can do this to convert this to. I don't. I mean, the only other thing maybe that we could pre-calculate the bit mask. But that's so frustrating though, isn't it? Like, Like, I don't know. Let's look at another one. How do they do it? Yeah, they did it the same way, except for even worse in theory with the constants. So I don't know. F max. Honestly, I don't know how to further optimize this. I mean, maybe I mean, they count the other way, but I don't know. Yeah, I'm confused, but am I doing anything? I don't see anything. I mean, there's not enough code to be obvious for me. Like, there's not enough code for me to figure out how to optimize this in an obvious way. Like maybe this, but this is like now changing like one or two things. This is not. I don't see any major things. Anyway, I'm not going to optimize this anymore, just because at this point, like I'm just copying and pasting from someone else's code, right? So that's kind of silly. Though I am curious, like, is it okay? Let's just copy their code then. I'm just curious whether this actually works at all. To be frank, yeah. Like, if I'm wrong, then like if this doesn't time out, then I guess it's fine. But it's kind of wild that, yeah, huh? What? Okay, now I'm crazy confused. Let's take a look at the performance. 12 seconds, so actually pretty good. What are we doing differently? I mean, the thing that we're doing differently is that mask. I think we do it different way. I don't get it, honestly. I mean, I guess this is a shift, but I don't think that doesn't change things enough, right? I'm so confused now. Is the F max even like? Is that the thing? Like, I guess at the margins this would be a thing, but that is such a stupid thing to do or need to do, right? I mean, yeah, okay, fine. Maybe I should have just copied one of the things and then benchmark it instead of YOLO submitting. But getting rid of the inline function or anonymous function, I guess it adds up. But does it add up enough? I don't get it. What is so different about this code? All right, let's take a look. Now I'm curious. I mean, the problem solving part is we already done, so it's fine. But I don't know why this takes so long to load. Is my internet having issues? Okay. And can I really do that much more different? Like, I'm now like looking line by line, and that's ridiculous, right? Like, I mean, is either like if is bit count that slow? I'm not. I don't have an internal thing about bit count, so maybe I should do it this way. Like, I don't have a mental clock on how much bit count is, whatever. But Wow, this actually takes a while, even just on like these one case. So okay, oh wow, 9 seconds. What was it before? Is it bit count? What did I have before? Was it this? Like, does it actually make a difference? Is that it? Like, I don't know that there's anything else really, right? There's a loop, a mask. So now this is 8 seconds. So my thing is faster. I don't get it. So this, the mask. I don't know. Is this the play? Is this even right? It's just not right, right? So I don't get it. Though it is a little wild actually. Well, the other thing is faster because it's just wrong, right? So maybe there is something to this statement that I'm writing, because that's a different understanding, right? This is saying that, okay, after mask, oh, actually this is wrong, this is next, but it shouldn't matter. Maybe it does eliminate things if I do this right? It's saying that, okay, it has met all the requirements from that state to get to this state, right? What does this mean? Okay, I think I need to rewrite this a little bit anyway. So okay, so let's just say, so P is equal to mass, so that means that can we do this one, right? And we can do this one if I is unused, okay? I is unused and all the prerequisite is and the prerequisite are done, right? So okay, so that's how they do it. And then in that case, why is it that much faster? I mean, it's just wrong, I guess, but also, why is this not giving me the right answer? I, parents of I. Okay, let's think. Okay, score P. Well, the P is P plus 1. I think that's why. So now we have to do the plus 1. Okay, but why is this so much faster? I guess it just does fewer states. But that's such a constant time optimization. I don't think like this is worth doing. Other than that, Leetcode is silly. I guess I get it, but like I get it, but it's also really weird. It's just that because this is basically essentially like a different type of pruning. Oops. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this poem, this video, this contest. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.